Hey guys, today we are going to talk about linear programming. So here's our problem. An aspiring artist group is preparing for a fundraising sale. They're going to construct two different types of antique reproduction tables. One of them is a semicircular foyer table. The other is a side table. For materials, foyer tables will cost $100 in materials, side tables $200. Both types of tables take 2 hours for cutting and carving. The foyer table takes 3 hours to assemble, sand, and finish. The side table takes 1.7 hours to assemble, sand, and finish. The group has $3,300 to purchase materials. They've got 40 hours available for cutting and carving and 63 hours available for assembling, sanding, and finishing. For each foyer table, they're going to get $350 income. For each side table, $215 income. How many of each table should they build in order to maximize their profit? So their constraints are cost of materials, time spent cutting and carving, and time spent assembling. We're going to write some inequalities for some different restraints, where X is going to represent foyer tables, Y is going to represent side tables, and I'm just going to make a note of that right here. X equals foyer tables, and Y equals side tables. The cost of materials cannot exceed $3,300. So for materials, for a foyer table is $100. So that's $100 per foyer table, plus $200 for each side table. And that cannot exceed $3,300, so it has to be less than or equal to $3,300. The number of hours worked on cutting and carving cannot exceed 40 hours. So cutting and carving time. So we've got 40 hours available. They both take 2 hours. So 2 hours per foyer table plus 2 hours per side table has to be less than or equal to a total of 40 hours. The number of hours worked on the assembling process cannot exceed 63 hours. So it takes 3.5 hours to go through the assembly process for a foyer table, and it takes 1.75 hours for every side table. So that's 3.5 for every foyer table plus 1.75 for every side table. That cannot exceed 63 hours, so it has to be less than or equal to 63. Because X and Y represent a number of tables, they can't be negative. You can't have a negative number of foyer tables or a negative number of side tables. So the number of foyer tables cannot be negative, so foyer tables are X, and they have to be greater than or equal to 0. The side tables also can't be negative, so the number of side tables, Y, has to be greater than or equal to 0. Okay, so we are going to graph each of those inequalities based on the constraints that we had, the equations that we made. So in order to graph, some of them we're probably going to want to put into slope-intercept form. So our first inequality was 100x plus 200y is less than or equal to 3,300. Okay, so we're going to put that into slope-intercept form. So I'm going to move this 100x over to the other side. So I get 200y is less than or equal to negative 100x plus 3,300. Okay, and then I can divide everything by 200. And I get y is less than or equal to negative 1/2 x plus 16.5. Okay, so I'm going to go ahead and put that on the graph. So our numbers here, counting by twos, it's not really a scale of two though. We've got 1, 2, 3, 4. So notice the 2 is above where the 2 actually is. So that means right here is 16, so right here is 16.5. And we've got a slope of negative 1/2, so that's down 1 and over 2. Okay, so we'll just keep going down 1 and over 2. Okay, so that's where our first line is going to be. Now, as an inequality, it's not just that line that satisfies the inequality, but it's everything that is less than or equal to that line. So what I'm going to do is test the origin, 0, 0. If I put in a 0 here and a 0 here for x and y, I get 0 is less than or equal to 16.5. And that is true. So it's actually everything toward the origin that satisfies this inequality. So on this line and all this space down here satisfies the inequality. I'm just putting these tick marks for now because I'm going to have a lot of lines and I don't want to start doing too much shading right now. So our next line was 2x plus 2y is less than or equal to 40. Okay, so I'm going to solve that one for y. So I'll move that 2x to the other side. So we get 2y is less than or equal to negative 2x plus 40. Okay, then divide everything by 2. Y is less than or equal to negative x plus 20. Okay, so this is 16, 17, I'll go 18, 19, 20. Okay, so there's our y-intercept, and the slope is negative 1, so that's down 1, right 1. I'm just going to go down 3, right 3 to get onto the grid. From there, I can just go down 1 and right 1. Okay, so there is my second line. Okay, so this one, if I put in the origin, 0, 0, I get 0 is less than or equal to 20, and that is true. So the origin produced a true statement, so I'm going to shade again toward the origin. And now it's this region here that has been shaded for both lines. Okay, my next line is 3.5x plus 1.75y is less than or equal to 63. Okay, so again we're going to solve for y, so 1.75y is less than or equal to negative 3.5x plus 63. Okay, then I'm going to divide everything by 1.75. So I get y is less than or equal to, okay, then I'm not quite so sure of these calculations, so I'm going to type those in the calculator. Negative 3.5 divided by 1.75 is negative 2, and 63 divided by 1.75 is 36. Okay, so I have negative 2x plus 36. Okay, 36 is pretty high up this y-axis, so I don't really want to use that. So instead, I know the slope, I'm going to use that, but I want to know what is the x-intercept. So in order to know the x-intercept, I'm going to put in a 0 right here for y. Okay, so that pretty much just makes that go away, and I get 35, or 3.5x is less than or equal to 63. So I'm going to do 63 divided by 3.5, and I get 18 as an x-intercept. So x-intercept is 18. Okay, now on this axis, 1, 2, it looks like the 2 is actually before where 2 actually is. On the y-axis, it was after, so we've got to be careful about that. So 18 is going to be right here. So that is my x-intercept. My slope is negative 2, which is down 2 and right 1, which is also up 2 and left 1. Okay, now for this line, if I test the origin, I get 0 is less than or equal to 0 plus 36. 0 is less than or equal to 36 is true, so that means this one also will shade toward the origin, which has narrowed my region down to this. Okay, now I had two more lines. One was x is greater than or equal to 0. That's a vertical line right here. Now I can't test the origin on this one. Okay, so the line was x is greater than or equal to 0. I can't test the origin because the origin is on the line. So I'll test 1, 1. Okay, so if I put in a 1 for x, 1 is greater than or equal to 0. That's true. So this one shades toward 1, 1. And then I also had y is greater than or equal to 0, which is right here. And if I test 1, 1, I get 1 is greater than or equal to 0, and that's true. So that shades this way. So I've had 5 different lines, and now I've got this region that has been shaded all 5 times. Okay, so this is my feasible region. Okay, so the region is the solution of the system of inequalities that shaded all 5 times. It's called the feasible region. It includes all points that satisfy the system. So everything on these lines and everything inside are points that actually satisfy all 5 equations. The goal is to find the optimal solution, which, according to linear programming, is one of the corner points of the feasible region. So one of these 5 vertices. Okay, so we're going to find those 5 different corners. So we've got 0, 0. We've got 18, 0. Right here we have 16, 4. Up here we have 7, 13. And right up here we've got 16.5. It's actually 0, 16.5. So what that means is the way to maximize income is either to make 0 foyer and 0 side tables, 18 foyer and 0 side tables, 16 foyer and 4 side tables, 7 foyer and 13 side tables, or 0 foyer and 16.5 side tables. So one of those 5 points will maximize our profit. Now we have to figure out which one of those 5 points. Okay, so to maximize our profit, first we want to write an expression that will describe the income for selling X foyer tables and Y side tables. This will be called the objective function. So our income, we learned on the first page, it's $350 for every foyer table, and it's $215 for every side table. So that is our equation for our income. Okay, now we're going to make a table to find out which of the 5 points gives us the best amount of income. Okay, so we're going to put our X's here, Y's here. We're going to use our income expression, 350X plus 215Y, and that's going to give us some amount of income. Okay, so our first point was 0, 0. Okay, so that would be 350 times 0 plus 215 times 0. We can probably do that math in our head. 0 plus 0 is 0. So to maximize our income, 0 of each table is not going to do the trick. So the next option was 18, 0. Okay, so that's 18 foyer tables and 0 side tables. So 350 times 18 plus 215 times 0. Okay, so we'll check on the calculator. 350 times 18 plus 215 times 0 is $6,300. So that would be our income for 18 foyer tables and 0 side tables. Next was 16, 4. So 350 times 16 plus 215 times 4. And that's $6,460. Okay, next up we had 7, 13. So that's 350 times 7 plus 215 times 13. $5,245. And our last option was 0 foyer tables and 16.5 side tables. Not really sure how we're going to do 16.5 side tables. It would either be 16 or 17. And with our constraints, that means we could actually only do 16. But for this expression, we'll put in the 16.5, 350 times 0 plus 215 times 16.5. I don't really need to do 350 times 0. 215 times 16.5 is $3,547.50. Okay, that's not the highest number anyway, so we don't have to worry about making a decision on the 16 tables instead of 16.5. Looks like our highest number is right here. So based on that table, how many of each table should this group produce? 16 Fourier tables and 4 side tables. Okay, how much money will they need to purchase their materials? So we may remember from page 1 that it costs $100 in materials for every side table. So that's 16 times 100 plus $200 for materials for every side table. So that's 200 times 4. So that's $2,400. That's how much it's going to cost to purchase their tables. So the last question is, what will their profit be? So their income on these tables was $6,460. Subtract the cost of materials, $2,400. So $6,400 minus $2,400 is $4,000. I didn't put in that number correctly, did I? So that would be $6,460 minus $2,400. So their profit is going to be $4,060.